We're going to give you a quick rundown and a little bit more in-depth look to expand upon what Michael was saying with our THK division. We have a lot of new stuff coming up, and we'd like to share that with you.
This is a presentation we recently gave in New York. It's a little bit on the salesy side, but that's kind of what we do. We sell Centrifuge. We don't sell technology. Well, we sell a lifestyle, too.
And coats.
So, yeah, if anything seems a little goofy, but it's just the way we put it together for New York. And, yeah.
Look at that. All right.
So this is Andre and me. We're from two ends of the spectrum when it comes to Centrisys. He's in the office in B2. I'm in the second floor on B1. Michael told me I wasn't allowed to give this presentation unless I was wearing some Centrisys swag, a polo or whatever. This is my swag. I'm upstairs in the lab. I'm running around with 5-gallon buckets playing with polymer, and on my end of the things, I'm in the process department. I work with the process of where we fit into wastewater treatment. We sell a machine that goes to a plant and produces cake. It dewaters, and from there, a lot of things happen. And we can do a lot of analysis on what we do and how we do it. And on here, I'm saying wastewater treatment plants are okay. Historically, that's been our bread and butter. They're regulated by the EPA, which is why the EPA is awesome. Every time they increase regulations, wastewater treatment plants have more incentive to buy our equipment because they have to dewater and they can't keep getting away with the tricks they've been pulling in the past. And industrial applications are even more awesome. We're getting into some really cool applications. Michael's been talking about minerals, and there's food applications that I've been working on with Tony, begrudgingly. And there's just a lot of potential for income and for sales revenue right there, and it's been really great on our end, and it's been a really interesting learning and growing opportunity, and I think we're really going to see that as Centrisys continues to grow. And we're forging a marriage of forces between me and Andre. Andre can talk a little bit about what he does and the sales, removing these products.
Yeah, absolutely. As Mike was saying, we're bridging the gap basically between engineering from a process-related standpoint, which is totally different than mechanical, which also, we need to bridge the gap to sales and keep all of our key components together as one. And obviously what Mike lacks in mechanical, he makes up with his coat. So we'll go to next. All right, you guys, this man really needs no introduction. Michael, you've got a chance to come up here and say, give us a good outline of what we do at Centrisys. We all know this is his passion, setting the bar a little bit higher and striving for excellence, and becoming an industry leader, whether it's dewatering, thickening, or just general wastewater treatment.
And now we're going to get into what we were told to talk about. It's thickening centrifuges. So thickening centrifuges, I've spent my last 6 years in school doing wastewater stuff, learning about different wastewater treatment technologies. And thickening centrifuges are today kind of thought of as an antiquated technology. They are seen as bulky, they take up too much space, it's big equipment. A lot of wastewater treatment plants don't have size to put these things in. They're unreliable and temperamental. When you change up your process, when you're throwing different feed sources into a centrifuge, an old centrifuge, not one of ours, it can't really handle that, and it can't handle that increased or decreased capacity, and it gets screwed up, and then the plant has to shut down, and then the EPA is getting on you again, and it's just, everything goes to hell. They're slow. They have a slow capacity and a slow energy hog, and that's something George kind of talked about earlier. We're increasing the capacity and the performance of our machines with new energy and new technologies, and they eat too much. Michael glossed over polymer, but that's why I'm upstairs in the lab running around with it. Polymer is very, very expensive to plants. They get mad at me when I say we have a relationship with a company called Ashland. We get it pretty much for free from them. That's because I'm upstairs in the lab trying to figure out which Ashland product to test for a plant and which polymer makes our product work best. Because at this point in the industry, with dewatering, you have to use polymer. But with thickening, we're getting away from that, and we are in a market, and we're at a position where we can save plants a lot of money. And that's why Michael's very excited and grinning creepily.
No pun intended with this slide, by the way.
Yeah. Nothing was intended there. Andre?
All right. Let's take a brief look at some of the current and historical alternative thickening technologies. We won't spend too much time on them, but to give you a brief run through, we're talking about gravity belt thickeners, gravity concentrators and thickeners, rotary drums, the DAFT as seen at Kenosha, and so on. And of course, there's always the good old centrifugal thickening. That's pretty much where we come in, and we've had the distinct advantage of looking at all these former technologies, looking at their pros and cons, and taking some of their weaknesses and so on and making them our strengths. So with that said, Mike can tell you a little bit more about the Centrisys twist on our THK division.
It's just that, it's a twist. We came up with a proprietary air delivery system. We couldn't really share much with New York because it's just that, it's proprietary. It stays within this room, folks. It's our thing. And
except for the video.
We got a really good control at cake solids, and what that means is we're able to maintain the performance and the output of the machine, and if something happens, all you got to do is push a button and you'll see a response right away. With other old centrifuges, you had to shut down, you had to open it up, make a change, maybe change the polymer dose, turn it back up, get it back going. Maybe it was going to work, maybe it wasn't. You didn't know, so you're kind of guessing. It's a guessing game, but with us, we took that out. We also came up with a plow design for solids discharge, which was more of a mechanical thing. Andre can touch on that.
Absolutely. As Mike said, one of the biggest things anyone that's been in the field can tell you about when you're doing a demonstration or optimizing a machine, shutting down and having to make a mechanical adjustment is something that you don't want unless you just have to do it. So where we come in, one means we have of handling the grit and trash on a lot of these thickening applications is our proprietary plow design, which Michael shared a little bit when you've seen the cross-section of the machine. Kind of stole our slide with Stokes' Law. I'm just giving you something.
Still have our presentation, folks.
But no, really, the design of this machine is extremely effective, and it offers us some solutions. If you want to continue on here, Mike.
So in the end, we've been doing a lot of analysis, which we'll touch on in a minute. Our product is energy efficient, it's smaller, got an immediate cake response, and we have no, emphasize no, to minimal polymer consumption, which is really, for those of you that aren't really in this end of it, it's really a big thing for us. And a big concern with New York, and we were kind of back and forth whether this was a little too soon. They had a lot of issues with Sandy. And without influx of rain and influx of water, that changes your feed significantly and what your plant operation has to do. From a process standpoint, you got to respond to that. Your plant can't just shut down. People are going to keep doing what they have to do in the bathroom. Things are going to keep happening. You can't just close that valve, and your equipment has to keep performing. We were able to produce equipment. We are able to produce equipment that continues performing, and you don't really have to batten down the hatches. We are trying to get sales to sell it at a certain design capacity, and in the inference that if you do get a big rainfall, if you do get an influx of flow, we can maintain performance at 200% with few changes. But of course, sales is probably going to start selling them at that 200% flow, and then it's going to become process's problem again. And now Andre can touch a little bit more about the design and why.
Okay.
That is.
This isn't the first time you guys have seen this slide, but further on what Mike was saying with the capability to handle some of the upstream fluctuations, whether it's due to solids loading or extremely adverse wet weather conditions such as Hurricane Sandy, our machine is able to regulate. The weapons we have to do that are obviously the differential speed, as in any centrifuge. And some of the other things that you notice, we have our proprietary design, again, with the plows, the air injection, which combined with the hydraulic effect and the air, that's what we've dubbed our Hydro-Pneumatic control of the cake solids. This is how we're able to really precisely control it within a fraction of a %. And obviously the other big thing that you'll notice is there's no conical. So again, this is setting the bar a little bit higher, going out on a limb and trying something new here, and we've proved it at various sites. One other thing I'd like to point out on our design to help handle those large fluctuations, for extremely adverse conditions, we also have the option to inject a small low dosage of polymer. So traditionally, where other manufacturers or other technologies are talking high dosage polymer for mediocre results, we have a proprietary design to inject eternally and treat just a portion of the flow instead of the total flow of sludge. Okay, so this is where we differ and we save polymer. Let's take a little bit closer look. You guys are all familiar with this. This would be Kenosha. Their existing DAF bays, they have twin bays basically running at all times existing, and we were able to come in with our CS18-3 thickener, and you can see we're 1/30th the floor footprint compared to the DAF. We like to laugh and say next time you're there, feel free to take a dip in their newly installed swimming pools.
Oldly installed.
There you go. So again, another feature to point out with our self-contained thickening unit, we don't have to worry about some of the other drawbacks, such as like with the GBTs, they have the odor control, vapor control. Here you're exposed to open fluids and you know, the mists and everything else from the DAFs. Exactly. So it's a much more hygienic, and much more hygienic operation. Everything's self-contained and so on.
Well, before Andre moves on, we sat in a presentation in New York, and this guy was trying to talk about his DAFs, and he was talking about an installation, and he said, well, all you have to do is install air ventilation. Well, it's not as simple as that. I took air quality control. That's a big installation there. That's something you have to monitor regularly, and if you don't ventilate this properly, people can get sick. That's a long-term thing. That's a big long-term cost, and simply by enclosing our bowl, we've cut that out.
Absolutely.
That's a big deal. People, our competitors like to say, "Oh, just do that." It's, you know, it's a lot bigger and it's a lot, you know, it's to our advantage. We've got huge gains.
Well, not to mention some of the other benefits. Again, with our unit, I like to pick on the GBT sometimes because we had the pleasure of sitting in their presentations in New York. But there's other things besides odor control, where we have chemical buildings, we have polymer buildings, we have all these different buildings that you have to take into account when you look at the volume and the footprint. It's not just that unit. There's more to it than what you see there. What we'll see now is a demonstration we did at Kenosha on our 18-3 thickener. Basically, the purpose of the video is to show how rapid the response of our, and how precise the control of our cake solids is from a simple regulation control change at the panel. And let's take a look at that for a moment before I continue. On the right side, you'll see the sludge, left side centrate, and here's the control. So obviously we run a dilute cake first, make a simple adjustment, and within maybe a minute or so, we have an 8 to 10% cake. And you can just as easily thin the sludge back down by adding the air, slowing down the differential speed to get you back to your 3 to 4% cake. If you watch this and let it loop through one more time, what I'd like to point out is if you keep your eye on the centrate, you'll notice no adverse impact on the recovery, which typically, if you go to alter the sludge and the thickness, it would require, historically, it would require a mechanical adjustment, which would also impact the recovery.
Looping through one more time, that centrate on the left is typically going back to the head of the plant, and it needs to be retreated again, reprocessed, and that's a big cost to the plant. If they keep cycling this water, that's money to them. The thicker that cake gets, the more solids are going down the line and into their process, and they don't have to keep retreating this, and you know, it's cutting out this process, and it's more advantageous for the plant.
Right, and you know, again, as we said in the previous slides, with wet weather conditions, heavy solids loadings, and fluctuations upstream, this regulation method can account for those by reducing the air or diff speed or so on.
One more side note, this video had to be reshot because in the top right, Andre was using the wrong finger to change the controls.
There's no proof of that.
But that stays within Centrisys.
That's internal. All right, to further validate our control of the cake solids, Bob Havern had the pleasure of going down to Pinellas, and he loves to tell this story. But to kind of wrap it all up in a nutshell, they gave us an operating range from 3.5% to 4.5%. This is the cake they want coming out, okay? So it's not always thicker is better. There's actual set points that are dictated by the plant and their downstream pumps and so on. We were able to fall within that range 80% of the time on a test that was manned by plant personnel, not Centrisys personnel. Whereas the competitor Centrifuge, which I believe was Sharples at the time, they were able to accomplish this feat 0% of the time. So you can see how precise this cake manipulation is.
Another thing I should note on is some people might say, okay, Mike just said you want as much solids going into that centray as possible. Well, why don't we just get as thick a cake as possible and call it a day? Sometimes, which is the reason this plant wanted a lower cake range, the target of 3.5 to 4.5, is because once you get a 2 cake, you still got to pump it down the stream to your tanks, to your digesters, to whatever. Once you get a 2 cake, too thick, you can't pump that, and it becomes a problem. You got to buy bigger pumps. You got to do this. You got to do that. So if you're able to maintain this range, that's good because you're not screwing up other things down the process. And those, I'll touch on in a minute, are fringe benefits, or as Michael likes to call them, French benefits. And then, well, this is still me. Then we came to Bob in terms of the process. The bursting of our bubble. This is Bob Havern. You guys have probably seen him skulking around Building 1. This is him in Beijing. He's actually a great guy. I work with him in process, and he's really helpful. And in terms of the THK, we had to do extensive and validation testing of the equipment and analysis by our oldest and most experienced engineer. I sit in the office, and when I'm not in the lab, and I look at him typing away on his computer, putting up confusing graphs and throwing numbers at me, and it's a lot of fun.
Good old time.
And continuing on that Bob phase, we're continuously monitoring the equipment. This is a pull-up of Kenosha, the equipment that's in our backyard. And this is our old monitoring phase, which Corey is currently remodeling. And the important thing to infer from here is we're maintaining a low torque in the pull and a steady process. Andre wanted to elaborate on that.
Yes, I can go in a little bit more detail. You guys are mostly familiar with what we've done with the remote monitoring, and as Mike said, the current one is even more powerful. We have the capability to adjust things on the fly, as Michael had mentioned. But the important thing to point out here, and this is just an instance, we can look at this real time or go back over the months and take different charts and so on. But if you look at this given instance, they were running a total of combined power of 7.63 kilowatt. Nice, stable, low bar pressure, which translates to a low torque operation. What do we have here, Mike? 4.7 bar at 131 gallons per minute. So what this means to the customer is basically this comes out to 0.059, 0.06 kilowatt hour per gallon per minute power consumption, where traditionally most centrifuge thickening technologies is running 0.15 to 0.3. In some cases, 0.35 kilowatt hour per gallon per minute.
Another good thing to note about the continuous monitoring is we can spot trends over time. You can look at a graph on a day and say, oh, crap, I'm running high power, something's wrong right now. But if you monitor trends, you can say, okay, maybe upstream something's going wrong with my process. Maybe I need to clean out a tank or look at a pump and send it in. You monitor trends, you can really keep an eye on your equipment and say, okay, in March we got to take it apart and service it. And that's really good for our client. So in terms of the validation, we told Michael to hit the road and get some results.
All right. As you guys recall, last fall, we went down to Miami several times. Our basic goal here was to test our thickener under various sludge conditions. This is no polymer operation. As you can see, we're recovering very, very well on the centrate. The goal typically was 4 to 6%. Solids or cake coming out of the machine, which is a very typical spec in this industry. As we said earlier, more due to downstream limitations such as rotary lobe pumps and so on. You can take another look here. This is a sample off of that actual operation. And by the way, Michael's smiling in there. I'm assuming we did pretty good.
He had them whitened for the video.
Mike can share a little bit more about validation on that. We photoshopped it, all right.
That was one of my editing tasks. So we started in Kenosha with a waste-activated sludge, just in our backyard. We had a test out in Madison. We went out to West Knox, Kentucky. It was Kentucky. Was it Tennessee? Whatever. I was there. I should have known. Well, they didn't correct me in New York. We were in Miami, Key Biscayne, Pinellas, Dusseldorf, and Beijing, and Singapore. And the important thing to note on here is we tested a variety of sludges and a variety of feeds. And even on site to site, your sludge changes, and that affects your machine performance, because if you get a sandy feed, that can wear down plates in the bowl real quick, real fast. You got to be able to respond to that and be able to say, okay, you're going to want to run at a lower torque. You're going to want to run at a higher torque. You know, Beijing, you're not going to run the same way they're running in West Knox, Kentucky. But you know, we work with them and we analyze this and we put it together for our clients. So that's a big edge on us.
All right, let me take a little bit closer look here at the energy efficiency of our THK lineup. What you're seeing highlighted here in orange is historically, this is where dewatering centrifuges and even current Centrisys dewatering centrifuges and early thickening centrifuge power consumptions have been. Over the given capacity, we see the kilowatt and the powers. So what we've done with our THK unit is actually take that and extend the range. So let's take our CS183 THK unit, where we've been able to go up to 250 gallon per minute and projected levels even higher under certain sludge conditions. All right, so what this means for you, and this is a key point for you guys to stress, is going to be greater capacity throughput at lowest energy consumption.
And now, this is my slide. I'm going to talk about the other big P word that a lot of people think about is polymer. Like I said before, it's an expensive resource for a lot of plants, and they really want to know how they can get rid of it, how they don't have to buy it anymore. So if you look at this graph, here's where we stand. And these are other thickening technologies. We've got a DAFT on the left, and then we got gravity belt and rotary drum. So they're clearly in different ranges. Where we are is we can get a higher cake solids depending on what the client wants, and we can minimize less polymer. And that usually we're running at no polymer, and the only instances where we run at polymer is where we want to increase the capacity and maximize the cake solids. And usually, like I said before, we don't want to hit that 10% with the thickener. And in terms of savings for the client, we estimated at 1 dry ton, 8 pounds of dry ton dosing, that's $140,000, and we cut that out.
Right, and that would be typical for what we've seen on our 18.3 unit. And what the current prices right now, Michael, you probably know this off the top of your head, $2 to $2.50 per pound of polymer is a pretty good figure. Yeah. Right, so that's where this actual formula is determined, and the 8 pound per dry ton is a very typical spec for a lot of the competitors. We've seen as high as 16 to 18 when we were at the New York presentations.
That's a lot of polymer.
That's a lot of polymer. So, I mean, your cost savings would be even greater at that rate. All right. Let's take a look at the, historically, the industry no polymer standard for centrifugal thickening has been, for the most part, between 85 to 88%. These are the levels that people strive for. As you can see, the flow rates are moderate at best. What we've been able to do with our THK unit for the same size machine is extend the range, and we're looking at flow over the bottom here, while also increasing the recovery. The next phase, as we've been discussing, is to treat it with a low dosage of polymer. We're able to, again, increase the recovery up to 90 to 99.9% versus the commercial spec, which has been basically 90 to 93, 94%. What this means for you is, again, greater flow rate, greater recovery, and dosing with low dosage of polymer where needed.
So Andre just said we got a higher recovery, and basically what that means is you're not sending solids back to the headworks of your plant. You're able to send that down on its merry way down to your digesters, which is what we're going to talk about in a second. We can hit that increased solids, and you don't have to heat these digesters. You've increased the capacity, and it's less heat generation required to maintain. That's very rude. less. I get to order more stuff for the lab now. And so that's less heat generation required for that digester. And in a nutshell, we basically just say that's 50% cost cutting right there. So this is where we came to our conclusion at New York. I'll come to a conclusion here. With our equipment, there's losses and gains. We have an increased hygienic operation compared to our competition. This bowl is completely enclosed. You don't have to come in contact with the sludge unless you want to, which we usually have to because we're doing testing, but such is the case. Digester capacity, which I just touched on, less heat generation required, more money, increased energy efficiency, which Andre touched on, increase in cake manipulation, you've got a controlled process for the plant, reduced space requirement, that's one small machine right there compared to what our competition's putting in there. There's a GBT sitting in the shop, which I don't know why it's there. Michael's buying GBTs on eBay. He's coercing with the competition. But that's a small machine. Compared to that GBT that's in the shop, this is a lot smaller. And like I said, reduce heating costs, reduce ventilation, and reduce operator attention. In New York, they had, I think it was like 36 machines or something like that. And they wanted to run with like no guys there. And we're trying to get there, but right now we're at like one guy. And that's pretty remarkable not to have a man sitting there running these machines.
To further on that point, I mean, if you take our installation at Kenosha, we're really a 24/7 operation. Occasionally, and this is just standard practice, even with their old DAF, they'll have an operator come in, I believe 3 times a day, take a sample. You know, if something's wrong, you know, he might make an adjustment, but it's really a 24/7 operation. One time a week, they shut down and, you know, grease the internal bearings. So what they ran into at New York, as Mike was saying, was basically they had to restaff it and actually make 3 separate projects for, you know, to put the fire out basically and get an immediate solution to their problems just to keep the operation flowing. Then it was a short-term solution, and beyond that, it was okay. Long-term, what are we going to do to solve this issue we're having? Way too many man hours. Even mechanically, the equipment wasn't holding up.
New York's an interesting operation. They had a $2.5 billion budget, and I think they're at 4.5 now.
Right.
And hopefully we're trying to get in there and let them throw some of that money our way.
Well, we have some things to improve upon it, that's for sure.
Oh, last one, little to no polymer costs. And what that means for our client, they don't have to get creative with their polymer. Clients really try to do different things. Been to a lot of plants where they'll say, okay, we bought a centrifuge, now I'm going to run it on drips of polymer. And I'll say, that's not how we told you to run it. We're not going to guarantee that. And they say, well, polymer's expensive. We don't want to pay for it. I'll say, that's not my problem. But we're designing new equipment where they don't have to pay for it. And they don't have to get creative, like cheating on polymer. And there's also the installation and continued delivery costs. You have to come up with polymer systems. You have to monitor these systems. You have to maintain these systems. Cutting that out is really big on a plant's end.
Right. Oftentimes there's even polymer buildings and transfer pumps and heating those buildings. These are things that aren't taken into account on their power consumption either. So keep that in mind.
On our test trailer, it's just a few little 5-gallon buckets, which we have to lug around, and even that's a pain in the butt. And Bob Avern will be the first to tell you, but if you can cut that out for a plant, they're doing like 500-gallon totes. That's a big deal.
All right. Does anyone have any questions regarding anything we do with our THK division or sludge thickening in general?
Josh, put your hand down. I think Jack has a question.
I don't want to get in trouble. Oh, the mic, sorry.
Mike.
Hey,
Mike with the mic,
Right. Hey, what are your recommendations for the sizing? What should we promote our original sized unit at? And do you know what the equivalent gravity belt thickener would be?
I'll walk over to Andre. We can share the answer.
All right. I don't think I need that. But, yeah, I mean, as far as sizing goes, it's going to come down to site-specific. What does the plant need? Miami would be a perfect example. This is a 285 million gallon per day plant that's looking to run over 5 sites. I believe it's 1,200 gallon per minute per site. So, I mean, you know, theoretically, you could run this through 2 very large machines, or you could do what we've done and offer 26-inch units. So instead of, if you need to add a 3rd machine, by all means, you run a duty standby setup. So typically there, the 18.3, again, it's dependent upon the sludge conditions. But let's take a typical example at 1% sludge under normal conditions, waste activated. You're talking typically 80 to 200 gallon per minute on the 18.3 size unit. And you can, in most scenarios, get away with no polymer on that unit. If you'd like to extend that range, increase recovery, you can go to the low dosage polymer. For the Miami jobs, some of the larger plants, we would be focusing on our 26-inch unit, which is being designed to run 600 gallon per minute, around 85% duty cycle. Any other questions, Tad? This is for the video.
Okay.
It's going to go viral.
On the primary sludge that you ran at Kenosha, what did you discover? Was it any different than what did you have to do to get the content that you needed to?
Primary is a completely different animal. Basically, what you have to remember about primary sludge is this stuff, as seen at Kenosha, has the capability to settle to 4.5% under 1 G. So when we run this through the centrifuge under 3,000 Gs, the material comes down extremely quick and extremely heavy. So your goal is to get this material out of the machine as quickly as possible. So primary is again still something we're just now getting into, just now testing. We were able to optimize for lower flows at Kenosha. And again, it mostly comes down to how quick can you get rid of the solids. Michael, did you have something to add to that?
Well, before Michael adds something, Bob was the initial testing of primary. He did a little bit of work on it. He's in Florida, but it's an ongoing thing. We're trying to work with it and expand that.
For the thickening of the primary, it's a work in progress, as well as primary settles very easy. We might not even have to use our THK design. We just can use a standard centrifuge and get it done. But we will optimize the THK design to optimize the flow rate, because if you think about it, if you have a feed solids comes in close to 5% compared to 1%, it's 5 times as much solids. So therefore, the design is going to be slightly different in comparison.
Absolutely. So it's exactly what Michael said. And, you know, a perfect example, again, if we're running 100 gallon per minute with the 1% feed, if we, you know, bring that to a 5% feed, you're basically looking at around 20 gallon per minute because of the offset in solids loading. So, Josh, I believe you had a question?
Yeah.
I think he's just trying to pick on Mike.
No,
but
I just had a question. On the slide with the globe or the testing locations, I saw that some of them said that we were thickening, we tested return activated sludge, and
yes.
I'm a little confused. I guess I don't see what the purpose of doing that would be, so I was wondering if you'd elaborate on that.
I think Michael would probably have the best idea on the purpose of the return activated sludge, and that's correct. We did run that in Miami and a couple other sites.
We didn't run return activated. We run mixed liquor there, and it was mixed liquor we run. I have no idea why people want to do that.
Yeah.
They just want to concentrate the concentration in the aeration tanks. That's the only thing there was. But we run mixed liquor, and I do not know why we run mixed liquor. I've never concentrated mixed liquor, period.
It's an R&D thing. You know.
Nonetheless, we've been very successful.
Yeah, nevertheless,
with it,
we were
yeah.
able to concentrate the mixed liquor to about 3% solids.
Yes.
While Josh was gone for 6 months, a lot of things happened, a lot of research happened. We tried new things. We expanded our scope and expanded our mindset. Any other questions?
It's all that playing in Denmark, Josh.
Louis?
I was just wondering how much long it took you to do all these tests that we talk about, and why you guys keep this in Florida, not in California? Do you have a passport?
Hey, I'm just the mechanical engineer. I don't do the scheduling. We will be headed your way soon.
Okay. Thank you very much.
All right, I guess. Oh, one more?
Just about the mixed liquor at West Knox, wherever that was. Their mixed liquor waste activated sludge was about 0.5% concentration. and they were going to a belt press, and so they had to increase the concentration. So that's why they were actually looking at the thickener. And they're looking at going on to the new plant will likely have a centrifuge rather than a belt press. And even then, we looked at the economics, and it's economical to put the thickener in front of our centrifuge on the new plant.
Thank you, Tony.
Anyone else?
All right. Thank you, everyone.
Thanks, guys.